Hello, everyone. Welcome to this new Sydney Testers meetup. Today we're having a wonderful tester, automation tester and trainer. His name is Bas Dijkstra. He blogs regularly on the subject. He does training courses around the world, and he really knows his stuff. And I believe that you'll really be engaged by his talk. Before we start with Bas, I'll show you some slides from to introduce Sydney Testers. We do this at the start of all our events. And so this is Sydney Testers talk, deal with dependencies and test early and more often by Bas Dijkstra. And that's, you can tweet at Sydney Testers. Hashtag is SydTestBDijkstra, at Bas Dijkstra as well. So let's just move on to the next slide. Okay, so just to introduce what will happen today. There'll be 5 minutes of introduction by me, which you're seeing now, and there'll be a talk by Bas, followed by Q&A at the end, and we'll also do a short Q&A in the middle as well too. If you have any questions, then please post your questions in the YouTube live comments. So this is a YouTube live stream that you should be watching, and and if you post a comment in the live chat, we can see it, and I'll pose a question at the right time. So sorry about that, I accidentally hit the wrong button. So who are we? We're Sydney Testers. We're a group of volunteers, a lively exec committee with a focus on improving testing and promoting testing as a craft here in Sydney. We organize monthly events, socials and other events for the testing community. And now we're online. We'll be running online events for a bit longer while COVID-19 is still happening. We will be doing in-person events within the next couple of months. We have a wide range of local and international speakers. Recent speakers have included people like Michael Bolton, Trish Koo, Richard Bradshaw, Rich Rogers, a wide different set of names. And if you want to get involved, speak to us. And as we usually do, we thanks to our ongoing sponsors, TestEd, who have always who has been involved in helping to run our events and sponsoring things like food for quite a long time. We've always had a good relationship with them. And please let me introduce to you to Bas Dijkstra. Hello, Bas. How are you?
Hi, Paul. How are you doing? Thank you so much for having me.
Oh, thank you. No, thank you. It's a real pleasure having you. Having you speak. Tell us a bit about yourself. I tried to introduce you a little bit.
So yeah, well, you did a wonderful job of introducing me. Really, I now have to downplay all of that. So yeah, I'm Bas. I am in the Netherlands, where due to the whole COVID thing, I am sort of kind of stuck at the moment.
Yeah, sorry to hear about that.
It is, yeah, it is, but it's been, yeah, at least we're all in this together.
That is true, yes.
So yeah, I've been in the testing space for around 14-15 years now. Mostly as a consultant for the first 8 to 10 years, and then I branched out into a little bit of blogging, a little bit of public speaking, and for the last couple of years, mostly as a trainer as well.
Okay.
So focusing mostly, as you said, on test automation, which not coincidentally is also the name of the company that I work under, that I own and am the sole employee of. And one of the benefits for me of this, one of the very few benefits of this whole COVID situation is that things have seemed to gotten both local as well as more global. because I'm not sure we would have done it. I'm not sure I would have been here if it weren't for COVID, because
I understand.
I am from the other side of the globe.
Yeah.
I am in the Netherlands. But what I've seen is that by net and all the activities have both become much more local. But since everything went online, things have got more global as well. So
that's true. I think we've been able to get a much wider range of speakers since we started doing online events, and we've been able to do more events as well. And so it has been. It's a shame that it came about through a real tragedy, but the online experience has really helped testing and brought different types of speakers and different ideas to the fore.
Yeah, I've experienced the same, really, and the only additional challenge is that we have to juggle time zones now.
Yeah, that is true.
So it's actually just after 8 a.m. and this is officially my earliest talk ever. So apologies for that if I sound a little not awake yet, but
no, you sound perfect. You sound perfectly fine.
It is. I'll probably go. I'm really happy to be here. I'm looking forward to the talk.
Well, thank you for your talk. I mean, we really appreciate it, and the group has been looking forward to it. Would you like to share your screen?
I am going to do that right now. Here we go.
Okay, that's your screen's now shared. I'll remove myself and I'll let you start your talk. Ladies and gentlemen, Bas Dijkstra.
Thank you so much, Paul. I was going to say good morning to all of you, but since most of you are probably somewhere in the Australia region, it's actually good evening to you. On Meetup, when I checked the list of attendees, which is what I do because I'm curious, I saw some people from my neck of the woods. So good morning to you. If you are attending this live as well, good morning. For those of you in other parts of the world, it's good afternoon, good evening, or good night. Thank once again, Paul, for having me. I'm going to share with you some of my experience with dealing with dependencies, how you can get around troubles in your test environments, and how simulations can help you test earlier, more and more often. When I was preparing this talk, so this is a brand new talk for me as well. So when I was researching this talk, I kind of got distracted, and which is what I do, which is what the internet does to you, really. And I recently learned that this fellow from Nova Scotia in Canada just a couple of years ago set a new world record for juggling chainsaws. He managed to throw and catch in a juggling movement 105 chainsaws before. Well, and the story didn't really say that, before either dropping one or getting seriously injured. But since it was recognized by the Guinness World Book of Records, I am just going to assume that it all ended well and without too many bloodshed, really. I didn't know there was an actual world record for juggling chainsaws, but I learned something new that day. And you might wonder why on earth am I sharing this story with you? Well, in some strange way, that's probably just the way my brain works, is that this reminded me of the topic that I'm actually going to talk about today. As applications and software systems get ever more distributed and ever more built out of loosely coupled, individually developed and deployed components, integration testing and end-to-end testing has become harder in a lot of teams that I work with, a lot of organizations that I consult with. They have so many troubles dealing with all of the dependencies in their testing environments, and every time they want to do some integration testing or end-to-end testing or test how their application works in unison with a dependency or a range of dependencies in their testing environment. They have to jump all these hoops. They have to juggle all these moving parts, and every one of these parts it sometimes feels like it's trying to kill them. But it's so hard to stage a testing environment where all of those dependencies are in place, are in the right state, and are available for the integration testing and the end-to-end testing that those teams want to do. And this is even more so if and the more often that teams want to do a test run and want to test a new version of their software, which with all this move to agile and continuous integration, it is more and more often because these development cycles are getting ever shorter. The trouble, the problems that they feel, the bottlenecks that are presented to them in form of hey, testing environments or components in testing environments not being available, is becoming a problem more and more often because they have to deal with these legacy systems or these third-party applications or other components that are still under development that are just it's so hard. It sometimes it feels like juggling chainsaws, really, at getting staging a testing environment and getting a testing environment ready and allowing them to do all the testing that they want to do. And what I said, systems are because there are fewer and fewer monoliths these days, fewer and fewer isolated systems where everything is on the same server, everything is in the same place. There are, and the typical application has to deal with more and more dependencies because applications are becoming smaller, are becoming more decoupled, more loosely coupled. Test environment, setting up proper test environments is harder because maybe you want to, maybe the application that you're developing and that you're trying to test communicates with other components that are still under development, or you have to deal with some back-end system where it's incredibly hard to configure the right amount and the right set of test data because it is being developed and maintained and deployed and run by a different team, maybe a different department, maybe even an entirely different company, and you have no control over the test environment. Maybe you work, and this is especially true in government and in banking, maybe you work with mainframes and your team desperately tries to move to a continuous integration, continuous delivery kind of way of working, but you have to do some integration testing with a mainframe that's only available to testing for testing to your team every Thursday between 3 and 5. And it's really hard to do continuous integration and continuous delivery and deployment if you can only do that integration test with that mainframe for 2 hours once every week. Or you might have this third-party software as a system, software as a service component system that happily makes available for you a test environment. It's just that you have to pay for every request that you do. So yeah, there are fees required for using that third-party component, and that is going to be especially troublesome if you want to do regular performance testing, where you don't just do a couple of requests, but maybe tens or hundreds of thousands of requests. So these are all problems and challenges that we have to overcome in our testing environments. because our system under test and the software, the application that we're developing, is not something that lives in isolation anymore. It's so connected to all these other kinds of systems, which again can be still under development. There might be access fees associated with them. It's hard to set up suitable test data for in that adjacent system, in that connected system. Or the system is available to you, but only on specific days in specific time slots. So that is all keeping you from doing all the testing that you want to do. And that's why, and that's you were slowly going to move into the main part in the topic of what I'm going to talk about today. That is why I'm a big fan of using simulations during test execution. And when I talk about simulations, I talk about fake components or that simulate the behavior of the system that you are that your system on the test is connected with, but that you do not have control over. So why am I stressing that it is all about the behavior? Simulation, or as it's commonly known, mocking or stubbing or source virtualization, it's not about creating an exact copy of the dependency that you want to simulate. That's not important at all. It's not really important in what programming language that dependency, the actual dependency, is built. It's not important on what hardware it runs. It's not important what the technology stack looks like, really, as long as you manage to simulate the externally visible behavior of that system for your testing purposes. So the fact that your actual application is built in Java or in C# doesn't mean that your simulation has to be built in Java C# as well, especially if it communicates with you through standardized messaging formats or transport protocols, like if you exchange data with that component via REST API, all it has to do is expose that a REST API that behaves as if it were the real system. It doesn't really matter what's behind that interface, really, in the actual dependency, as long as you manage to build a simulation that acts exactly the same, or exerts the behavior that you need for your testing, for your integration and end-to-end testing. And now the end goal of doing this is to regain that control over your test environment, really, and to remove those bottlenecks that I've talked about in the previous slide. Remove those bottlenecks that are hindering, that are blocking your integration and end-to-end testing, by replacing them with simulations. And so, because simulations, especially if you build them yourself for your own integration and end-to-end testing purposes, these are available on demand. And because you build them, so you know when and where to deploy them, you have full control over them. You can inject, you can stage the test data in it that you can stage the exact test data that you need in there, without having to ask a different team or a different department or a different company to set up the test data for you. You don't have to share resources anymore, because every team can get their own copy of that simulated resource. And unless you are a very bad negotiator, you probably won't have to deal with these usage fees anymore. So if you have a dependency that is within your own control, it is free to use. After you apart from the cost of obviously of developing that simulation, because you're developing a component, or you're configuring a simulation, and of course that's not entirely free, but at least it will no longer ask you for a fee every time you send a request to it, and every time you ask it for some data, for example. And what you then hopefully end up with is a test environment where your actual system on the test is deployed. And because instead of the actual dependencies that are causing you these troubles, you are testing with simulations, it gives you much more flexibility and much more power and much more options in your testing. And I'm sure I'm going to talk about this a little later on. This is not something. This is not a substitute for testing against the real thing. It is something that can help you do certain parts of your testing more efficiently. So I probably I'll get back to that previous slide in a bit. So what I typically when I consult with teams, when I try to help them with their problems in test environments, this using these simulations, it's not a replacement for testing against the real thing, because there is no better thing to test against than the real dependency. But as we previously saw, that might not always be possible. And how I typically talk about using the simulations is that it allows me to, it can help me to test earlier. It can help teams to test earlier, because I don't have to wait until the development of a component that I depend on, or a specific feature of a component that I need in my own system. I don't have to wait until the development of that component or that feature has finished before I can start do my integration testing with that component. It helps me to test more as well, because with simulations, it is so much easier to replicate specific edge cases, or stage specific state, a specific test data in there, or specific fault conditions. So for example, if I'm testing a web shop which has an integration with a payment service provider, and I want to test if my web shop is able to handle delays or outages or malformatted responses from that payment service provider in a proper way, and I have to deal with the test environment from that third-party payment service provider, it's going to be really hard, if not impossible, for me to recreate those fault conditions every time I want to do a test. Because I can call them and say, well, could you please unplug your test environment for a bit, because I want to, but maybe there are tens or hundreds or thousands of other teams and companies also depending on the test environment. So their answer is probably going to be no. With simulations, it is just another bit of behavior that you configure yourself. And so, well, if I'm sending this specific order with this specific data, I want my simulation to act as if it was really slow, or to act as if it returned a fault. And that allows you to do that type of testing, and that the exception handling of your actual system under test, for example, much more efficiently. And finally, it allows you to test more often. And this pretty much summarizes the title of this talk. It allows, because these simulations are readily available, and they are often, as we'll see in the demo, which is the second part of this talk, it's just something that you can ship together with your application and your test code. Yeah? And that, so every time you pull a new version of your application and your test code from your version control system, you'll also automatically have access to the latest version or the latest known version of the simulations of these dependencies, these components that your application depends on, whenever you want to do the testing. So there's no more waiting until that mainframe component becomes available every Thursday between 3 and 5. Again, it's probably a good idea to still every now and then test against that real mainframe when you have the time and you have the probability, because when you're developing simulations, you can make mistakes there too, and never just trust on testing against simulations, but it can definitely help you test more things more often and at an earlier stage of your development process, which I think is only a good thing. So there, I'm typically talking about simulation here. There are there's a lot of different terminology around with regards to simulation. Mocks, stubs, test doubles, dummies, fakes, spies, search, virtualization, and I found it pretty much depends on the person who you ask what their definition of which term is. So I'm not going to bore you with my specific definition of this, and I don't always. I'm not always consistent in my use of terminology either. So if you'd ask me now, I might just give a different definition than if you'd ask me a couple of weeks from now. What I do like though is I do want to point out is the link that you see at the bottom of the slide, which is an article by Martin Fowler where he explains his view on the differences between mocks and stubs and spies and dummies and stuff like that. So if you want a more formal definition of these different terminologies, that's probably the best resource I can point you to. How does this, so just to give you an example of how this can help teams do their testing more often. A couple of years ago, I was working as a test automation engineer for a large telecommunications company in the Netherlands. And part of their services was selling these triple play subscriptions, so for internet, telephone, and television throughout the Netherlands. And we were working on their back office order manager. And one of the dependencies of that system was another backend application that you could request that had a large database of available zip codes and also available addresses, so zip codes and house numbers. And it could tell you which kind of connection you could request there. So our system made several calls to that system during the process of creating a new connection, provisioning a new connection, and creating a new subscription. Now, every time we wanted to do some integration testing there, which was more often than we were able to, we had to call someone from that different department. It was the same company, but in a different office in a different city in the Netherlands. So we had to call them, and there was really only one person who was able to free up some specific addresses in that backend system, so we could simulate creating connections on those specific addresses. And it typically took him about a week to set that all up. And so every time we wanted to do a new test run, we had to request the number of addresses in advance, because you also couldn't reuse these addresses. And it had to be an existing address, so there was a lot of limitations around the test data. And then we did our testing, and that was it. If we wanted to do if we founded some bugs and we wanted to do a retest, we had to request a different set of addresses, which took another week or 2 weeks. So, and you can imagine that this took ages, really, for a new release to be thoroughly tested and being able to put that into production. And since that company wanted to release more often, we had to find a solution to that problem. And what I forgot to mention is that because everything was set up manually by this one person who was in charge of the test environment for that third-party dependency, there was no way we could do any automation at all, because there's just no because you can really only use addresses once. You have to come up with new address every single time, and and these addresses have to be set up in advance in that system, and we had no control over that system, so that there was just no way that we could even think about starting to automate some of that stuff and have that run unattended. That's what we decided. Maybe we should, because that was maybe we should just try and see if simulating that stuff helps us. And we spent about a week analyzing the traffic and setting up a simulation, because there really wasn't that whole interface wasn't as thoroughly documented as we thought it should be. But then we found out how that worked, and in the end, it turned out to be just one element, one flag in one response message that we had to change, because that indicated what this address that you requested is available or not. And building a simulation that just returned us that answer immediately made every single combination of zip code and house number, no matter if it actually existed or not, available to us for testing. So you can imagine that that was a major improvement for that team, for us, in terms of the ability to test earlier more and more often, because now we could just create new provision new connections and subscriptions whenever we wanted to. So we could think about, and it only took a couple of minutes now instead of 2 weeks. So we could think about, we could do more testing. We could do new do testing every day. We could think about automation to speed up our development and testing processes even more. And that really, and it's just by creating simulations for this one dependency, not even the most sophisticated of simulations, but just enough to help us do the testing that we want, was such a boost in terms of the ability to test earlier more and more often. And so that to me, that was one of the first times where I realized with the simulation, this is really something that can help teams to move faster, really. Of course, again, it was no replacement for testing against the actual system. They still did that from time to time, but they were able to do so much more testing, so much more often at earlier stages in the development cycle, that it sped up so that basically allowed them to release every couple of weeks instead of every couple of months, which was a big gain for them, and not just in terms of development, but also in terms of staying ahead of the competition, really. Paul, this concludes the first part of my talk. Any questions so far?
Sorry about that. I just had to put my headphones back in.
Sure.
No, there aren't any questions at the moment. Ashwini Ramachandran Muralitharan says, "Hello, good afternoon from China." I
India.
reposted your. Oh, India. Sorry.
Yeah.
Can't read.
No.
I also reposted the link that from Martin Fowler's article that you mentioned, just in case people didn't catch it. That's in the chat. I just want to say, are there any questions that people want to pose right now?
If not, we're just going to move on to the second part of the.
Yeah. If not, we'll just carry on.
Sure.
I've not seen any new comments, so. Oh, somebody, Martin van den Ende says, "Good morning from the Netherlands."
I saw Martin in the list of attendees beforehand, so that's how I knew that some people from my neck of the woods were also at least planning to attend.
I understand. Yeah, cool. I just want to say as well that at the end of the talk, we'll also go through the. I had a chat with Matthew, and we'll go through the training session that you're doing.
Yep.
I just want to promote it as well, but we'll do that at the end of the talk. Let's carry on, shall we?
Sure, no problem at all. Let me share my screen again. Here we go.
I'll drop off.
So, and now I've told you about it, the benefits of using simulation. How I can do that. Let's look at how this works in practice. I would like to introduce you to our application under test, also known as a parabank, or the world's least safe online bank, as I like to call it. It is a demo application from a tool vendor, which I like to use and abuse in a lot of these kinds of sessions and my training sessions, really. It's an online banking application, and one of its features is the ability to request a loan. And when you do that through the front end or through the public REST API that this banking application exposes, it actually invokes a third-party loan processor service, which is a service that is developed in a different department, in a different company, really. So it has this external dependency that you that is invoked whenever a user of this or a customer of this bank requests a new application or submits an application for a new loan. So this is the actual application. If I log in and say request a loan for $10,000 with a down payment of 100, deductible from this account number, it is going to tell me that my loan request has been denied because I don't have enough money. The actual loan provider name is World Securities Dynamic Loans, or WSDL. That's just a name, really, but it's going to deny me this. Now assume that I want to do some more intricate testing, really. I have this third-party dependency, this third-party loan processor that my application invokes every time I request a loan. But I want to know how my banking application works. For example, if that loan processor is responding, but responding really slowly. Or maybe I want loans that I don't have the option to create account, or it's hard for me to create account. I just want specific situations where loan applications are always granted, because that might depend on lots of different things that are very hard to set up in my test environment. I just want a predictable answer from that third-party loan processor. Or maybe I want to test what happens if that loan processor is down, is unavailable, for example. Now, as you can imagine, that's probably really hard. Those kind of situations are really hard to simulate if you're working with the actual third-party dependency. What I've done is I've prepared a simulation. So let's skip that one. Using a tool called WireMock. This is just one of the many tools that can do this kind of simulation for you. I happen to like it because it is powerful, flexible, lightweight, open source, and it does most of the things that I wanted to, especially for sessions like these. It is a Java-based tool. It only it only supports HTTP, so it's an HTTP mock server. It supports HTTP and HTTPS. If your dependency communicates over a different transportation protocol, so for example, MQ or JMS or SMTP or FTP or whatever, this tool isn't going to help you. But since more and more components are connected to each other over HTTP and talking via REST APIs, there are many situations where a tool like this can definitely help you out. Again, it's open sourced. It's developed and maintained by Tom Akerst, who is a chap from the UK. So all credit to creating this. All credit for creating this tool to him and not to me. I have no vested interest in using and promoting WireMock. It's just that I really like the tool, and I think it's easy to use and also to teach to others. So what I've done in preparation for this demo really is I've created a simulation. And this simulation is the way WireMock works is you can create the simulations either in Java code or through JSON mapping files, and both of them both lend themselves really well to being put in version control, being distributed by a mechanism like Git, for example. Which is what I really like as well. So again, you can then make your simulations and the simulation that's created part of your entire code repository, just like your application code or your test code would be. I've created a number of simulations. The loan processor service is actually a SOAP service, so it's a little more old-fashioned, really. But it is definitely possible because the service communicates over HTTP. It's definitely possible to exchange SOAP-based messages and simulate those transactions with WireMock. So it's not just for REST APIs. You can definitely do SOAP there as well. It's a little more cumbersome, admittedly, but it does work. What I've created is a number of situations, a number of simulated responses that make my simulation behave as if it was the real loan possessor, but with the conditions and the specific behavior that I want to use. So for example, this is my definition for the happy path loan response. So whenever a loan request comes in for an amount of 10,000, it is going to return this response, which is, so a loan request for $10,000 is always going to be approved. And as you can see, I've entered a different loan provider name in there, just to show you that we are now actually talking to the loan provider simulation and not to the actual loan provider anymore. I've also created a simulation that responds to, so whenever I submit a loan request for $9,000, it's going to respond with an approved, that request is going to be approved as well. But it'll take a delay. So with simulation tools like WireMock, I can also simulate performance behavior. So this is going to respond. It's just going to delay the sending of the response by 5,000 milliseconds, which can help you test how your actual system on the test, so in this case our online banking application, handles responses that do come in but a little slower. And so and if I send a loan request for 7,000, I'm going to send a a status response, a faulty status response in return. So this I can use to simulate the situation where I send a loan request from this banking service to this third-party loan processor, but that loan processor service is, or a downstream service for that loan processor is unavailable. So and this gives me much more flexibility and much more control in terms of being able to simulate these edge cases, these faulty cases, these delays in response times, for example, and how my actual application is able to handle those conditions really. So let's quickly fire up. It is, oh crap. So this I can use to this is starting the WireMock server, so it's running now on this port. The only thing I need to do now first before I start testing is, and that's also the good part about this demo application, I can tell which loan processor service it should use. So if this field is blank, it uses the default endpoint. But I can also say, well, just use the simulation that's running on that port 9876 on your own machine. So now I've configured my application to use the simulated loan processor instead of the actual loan processor. And if I now request a loan again, and say, for example, I want to request a loan for 10,000. I just want a really small down payment. It's going to be approved. And as you can see, because I've entered a different loan provider name, you can see that this is just confirmation that it actually talks to the simulation instead of the real thing, really. And now I can also test that does what happens if I send in a loan request. I remember if what I defined as behavior in my simulation is that whenever I receive a loan request with an amount of $9,000, it's going to respond, it's going to approve it. It's just going to send that response back with a delay of 5,000 milliseconds. So when I now click this button, it is going to wait 5 seconds. So it approves it. So I'm now able to test that my banking application can handle these delays in the third-party loan processor service, at least for a specific delay of 5,000 milliseconds. I could probably also increase that to 30,000 milliseconds, but well, for demo purposes, that would be a little. We'd have to wait 30,000 milliseconds there. That would be a little too long, but you get the idea probably here. So this allows me to test what happens in my application if that third party is reacting a little bit slower, if my application is able to handle that. And I can test, for example, what happens if the third-party loan processor returns an error status code. So remember, what I defined here is if the loan amount was 7,000, it responded as status 503, which is translated by my banking application, and which is handled by the banking application by showing this error message. This is, well, you can say a lot, but at least we're not. It doesn't show stack traces and stuff like that. So now we've been able to determine that, well, it's not as elegant as it should be probably, but our application is able to handle these outages or these errors from third parties in a sort of kind of graceful way. And this is this is really hard to do with the actual dependencies, because you can't just pull the plug on actual dependencies, especially when they're outside of your control. And so, and this this shows you how you can use these simulations for your exploratory testing purposes, for example. We can also use this in our automation. I've also prepared some automated scripts here, some Selenium scripts which simulate what I've done here in front end. I can also, as part of this automated test, I'm spinning up the simulation server just before the test starts. So I've took it down again, so it's not running anymore when I. So whenever if I do a loan request now for 10,000, which previously was okay, it's now going to time out because the service isn't actually there anymore. But as part of my automated test, I am also spinning up this. I'm starting this simulation server right because it is part of my test code and my application code, just as the actual test code is. So this allows me to use the simulations in my automation as well. And whenever I check out the latest version of my test code, I also have the latest version of the simulations that I need to do my test. So I've built a number of tests. Say, for example, let's take the one that takes a delay here. So this one logs into Parabank, navigates to the loan request form, fills it in, and asserts that the loan provider name is equal to this one, the one that simulates a delay, but that the loan request was still approved. So let's see what happens there. There we go. So here's the 5-second delay. But the test passes. So, and I could do this for all of the other tests as well, but they do sort of kind of the same thing, but faster because there's no 5-second delay from the simulated loan provider. So, and by doing this, by making these simulations part of my test repository, my test code repository, I can distribute them together with the automated tests. And this means that these tests, these integration tests that use simulated versions of the actual dependencies can be run as part of a continuous integration, continuous delivery pipeline at all points in time, because the simulation is always there. It is part of the test code. So that really helps you do the testing that you want whenever you want to do it, really. So that's it for the demo. All of the examples, so the code, the examples that I've shown are available on GitHub on this GitHub link. It's probably going to be up for a long time to come, so feel free to refer to that at any point in time, really. For those of you who want to know more about WireMock and want to get some hands-on experience with how WireMock works and what it can do for you and what the various features are, I have developed a free workshop which takes you through a number of the most important features of the WireMock tool. That's on GitHub as well. So that workshop contains exercises, examples, the answers to the exercises, as well as a complete slide deck that guides you through the entire process. So that is, and that for those of you who are interested in simulation and in WireMock as a tool, that might be a useful resource to get some hands-on experience with building your own simulations. Because WireMock can do a lot more than I can show you in this 10-15 minute demo. Finally, some words of caution. Not about WireMock, but about the simulation in general. I addressed some of those things already, really. But one thing to really be aware of is this is a Rube Goldberg machine. That's an incredibly complicated, and the definition of a Rube Goldberg machine is building an incredibly different contraption, really, to achieve an incredibly simple goal. So this one turns on a light bulb in the end, but you see there's a lot of and when you build these simulations, there's definitely this is definitely something to be aware of as well. I think I've already previously said as well is only simulate the behavior that you need for your testing. And the trick is the fine line that you need to walk is simulating just enough to support the testing that you want to do. It is incredibly tempting to just sort of rebuild the entire dependency there with all its business logic and all its edge cases. But if you don't need them for your testing, they have no place in your simulation. So keep it as simple as possible and try to simulate just enough to support your integration and end-to-end testing needs, and not more. And beware of building this Rube Goldberg machine. These simulations should be straightforward and easy to use and not as complicated as the actual dependencies, because then you're just digging a whole new hole for yourself, and you'll probably get stuck at some point in time. And please don't forget, I think this is the third time now that I mentioned it, this is no substitute for testing against the real thing. This is something that can help you test earlier, test more often, but in the end, you'll probably always want to test against the real thing. And if the real thing is available to you, you don't need a simulation at all. But for those cases when the real thing isn't available, simulations can definitely help you, again, test earlier, test more, and test more often. But in the end, you're not going to ship the simulation to production. So always, at some point in time, test against the real thing too. That's it, Paul. That's it for what I had to tell for now. I have a couple of closing slides, as you promised, but this is the end of the actual talk.
Oh, thank you so much. I really enjoyed that. And we've had a flurry of comments, a flurry of questions, for the Q&A. Should I just go through each one by one?
Sure.
Yep. Okay. The first one is by Georgi Kalnitsky. He asks, can you use WireMock to test what the system under test sends to the mock?
Yes. One of the features of WireMock is that it does verification. I don't know if for those of you who are familiar with mocking frameworks for unit testing, like Mockito for Java or Mock for C#, one of those the features is typically and not just send responses or create mocks for club, but also verify the calls that the class that you are testing in your unit test is making to that mock, and to see if the right methods are invoked with the right parameters, with the right values. WireMock has verification options as well, so you can, apart from sending back these predefined simulated responses, you can also put verification points in there. Will say, well, I want to check on specific properties of the requests that your system under test sends to this WireMock instance. So there are definitely options to do that. Probably your best bet, I don't know. Can I add comments to the chat?
Yeah, you can through the right-hand screen where it says comments.
So I'll just
the right-hand side of the screen where it says comments.
Yeah, I don't see a But I'll just pull it up. I shared my screen again. If you go to wiremock.org/docs, it has a verifying section there, and this pretty much summarizes what I just this shows examples of what I just, so the verification options of WireMock.
So I've just I'll just post a link to that actually myself in the chat.
Cool.
So people can refer to that one.
Yep. Thank you.
All great. The next question is from Ian Hong. He asks, the response can only map to a fixed value or in a request or map to a range, conditions or regex. He says, can the response only map to a fixed value or can it map to a range, conditions, or say a regex?
There are again, there is no time to to show all of the features of WireMock. That was also not really the purpose of the talk. But yes, there are. You have many more. You have many more options there. You can do regex matching. You can do range matching, specific conditions. You can map responses based on all kinds of characteristics of specific requests. Really. Again, either have a look at the docs because Tom has explained it perfectly there. In the workshop that I linked to in the slides, I'm also showing some examples and some exercises on how you can use that to do more flexible, more efficient matching.
Excellent, thanks. And what I've done is I've actually got the link to the request matching section, which I've just posted in the chat.
Awesome.
I'm showing now. Thank you. Next question is from Aswini, who asks, I mean, it's probably a bit late to do a demo, but could you demo one of the scenarios using API calls for using rest assured or Postman? I mean,
I can.
you can you? Okay.
I've done day 2 of my API testing masterclass yesterday, and part of the exercises is about that. Let me quickly share my screen again.
Oh, thank you very much. Yeah.
So it is. So there's a whole lot of exercises in here. Really, answers probably this one. All of these use WireMock because this is a rest assured course, so it's an API testing course, and a rest assured is an API client. But because I don't want to get bothered by actual live APIs that are down or not behaving as I want in my courses, I use simulations for all of those as well. So these API tests, this is an API test really, but it invokes like the Selenium test that I demoed just before. It starts a WireMock server just before I run the tests, and I write API test to test my mock implementation really. So this invokes my actual this sends a request to my local host at port 9876. If you want more examples, where I have a WireMock workshop, I also have a rest assured workshop. Not test project, but this one. This one follows the same structure really. But it's not to teach you the basics of WireMock, but to teach you the basics of rest assured. And this also heavily uses WireMock because I don't want to be dependent on live APIs whenever I conduct this workshop or whenever I give this code, show this code to somebody who wants to run it on their own machine. It'll just spin up a WireMock mock, and then you can use rest assured to directly talk against that mock server.
Oh, but excellent.
The principles are exactly the same as the demo that I showed that uses Selenium. Well,
thanks. I've put the links to that in the chat so that
I see one more from Coretta.
Yes, I'm going to read that one out now.
Yep.
In the simulation, when the loan is approved, I notice the date in the past displays. Is confirming that the current date displays generally part of the simulation test?
And here's where you can tell I've been a consultant for too long. It depends. So I've been a bit lazy with preparation of this. The actual response. Let me pull up the other project again, which is the one that we used for the demo. The actual response doesn't include a date field. And the Parabank application interprets that it just uses epoch time, which is January 1, 1970. That's why it displays that. But I could, if I weren't so lazy, I could have added a date field, and then it would have shown the actual date that I sent in the response. So if that is important for you in your testing activities, for your testing purposes, then you should have the simulation return that extra field as well. For me, for this specific demo, it wasn't important, so I took the lazy route and didn't bother to find out how to actually format the date. Really, that's what it comes down to, just laziness. But it can definitely be done. But then I'd have to pass the actual date back to the back via the. I'd have to predefine that in the response.
Okay. Well, thanks. I think that summed it up pretty well. Are there any other questions? I'm just asking in the chat at the moment. Because if there aren't, then I'm going to go and talk briefly, show the page for your Introduction to Behavior-Driven Development talk, which is on the 9th of December.
You've created the slide for that as well? So have I. So.
Oh, did you? Okay, I'll let you share the screen then. Because I was just going to put the web page, but I'll put the web page in the chat actually.
Thank you.
If you want to show the slide, I'll let you do it.
Thank you. So, as Paul already said, and I have permission from Paul and the people from this meetup to promote this, because it's actually organized by good friends of them, and they work. I am hosting a half-day Introduction to Behavior-Driven Development workshop on December 9, from at a time which is very convenient for the people in Australia, because it's from 2 to 6 p.m. That's Australian Eastern Summer Time, probably.
Eastern Standard Time.
Standard Time, okay.
So it's right now it would be 3 till 7 in AEDT, which is the time zone that we're in.
Okay. But these are the agreed. This is the agreed time and time zone. So this workshop is a hands-on introduction to the principles of BDD, on how BDD can help you solve at least some of your communication issues when you're designing and developing software. The link to the actual, if you want more information about that workshop, or if you want to know how to register, the link is right there, and I'm pretty sure Paul has just shared that in the chat as well.
Yes, it's in the chat.
Yeah, excellent. So for those of you who are in Australia, be sure to check that out, and who knows, I might see you there as well.
Oh, thank you. I'll see if I'm free. I'd love to come. But yeah, certainly. I think Matt, who's one of the members of our exec committee, and he asked me to mention this. I've asked. He's posting an event in Testers for it, which will just direct you to the page, for the event. So if you miss it now, you'll see it as a post in Sydney Testers that will direct you. So yeah, well, thank you so much, by the way. And
You're welcome. It was a pleasure.
Enjoyed the talk, and really enjoyed the talk, and I'm pretty, I would presume that lots of people, the people who watch the event, and the thing about, obviously, with it being an online event, is that people can continue to watch it later, or discover it. There are loads of people who say that they will come to the specific time, then they watch the event a few days later or a few hours later.
That's okay.
And they'll get to enjoy it as well. And I've got to say thank you so much for speaking. I enjoyed it.
Thank you so much for having me. Just in case people want to get in touch, I am far too active via email and LinkedIn. So when I should actually be working. If there's anything, any late questions or this for the people who if they want to get in touch or ask a question, just send me an email, hit me up on LinkedIn, and I'd be happy to have a chat. And thank you once again. Thank you so much, Paul, for having me. As I said, even though these are trying times, sometimes it opens up new opportunities as well, because we don't have to deal with the physical distance anymore, because this is an online event. We just only have to juggle the time zones now. But this allows me to talk at a meetup in Australia, which is something that I did not think I would be doing at the beginning of this year.
Yeah. This year is, as I said, it's made us change and completely overhaul the way that we work in so many different ways. But it created new possibilities as well. So it has
definitely. That's what I was trying to say. Really, yeah, it is. It opens up new possibilities as well. And yeah, unfortunately, there's a lot of people are still in trying times. They are, but yeah, that's just me trying to see it from the positives at least a bit. So yeah.
Well, thank you so much, Bas. We'll end the broadcast here. Bas, please stay on for a few more minutes if it's all right. But
No
once again, thank you so much, and to Sydney testers and to the people who are watching us tonight, have a great evening.
Thank you. Bye bye.
Wherever you are.